I'm Ray, and today I will demonstrate and explain about the specific bug that I found in Jira. The system is called Spark, which is data parallelization tools that use in so many big companies right now, and they use it for data parallelization, data processing, and data streaming tools. And the bug is actually a scalability bug, and it's called a memory leak occurs when we clone the Spark session. And we can see from the description, this bug happens when we keep cloning the Spark session. And because of that, a new execution listener bus instance will be added to the async event queue when we clone a new session. And today I will reproduce this bug inside the Chameleon Cloud, which is a testbed. And also I will package the experiment inside the Chameleon Cloud Trophy, which you can reproduce easily, in several buttons. Click. So after you open the trophy package, you will see the similar interface to this. And the first thing that you need to open, obviously, README IP YNB, which will guide you to run on how to run this specific reproducibility bugs. Just please read this instruction carefully, and then you can see that there exists the bug explanation as well, which will point to the Jira Spark entry that I mentioned before, and also the fix for these scalability bugs. And you can see the overview of steps here: the setup, IPYNB, experiment IPYNB, and analysis. And you need to follow this and try to run the setup, and then run the experiment, and then run the analysis. And if you are not familiar with the Jupyter interface, you can try to run this, right? Just click Shift and then enter here. And then you can see it will execute the Python code, which is the datetime library here. It's coming from the standard library of Python 3. And you can see that it prints out the date of the current date right now on the server. What we need to open, obviously, is setup notebook files, which we can double click in the sidebar here. And it will open the notebook file. And you can see this whole notebook is just the way I set up the experiment container, such as spawning the Chameleon instances. As you can see here, we try to reserve the Chameleon nodes, and then we will try to spawn the bare metal node, which the OS I'm using here is Ubuntu 20.04. And also we can see we are trying to save a session here that we will use to share throughout other notebook files. And also in here we try to install Spark as well, because obviously we want to reproduce bugs in Spark. It means that we need Spark in our system. And yeah, let's try to run this. And to run this setup, it may take around 10 minutes or like 15 minutes, because we spawn a bare metal node. So please be patient and just wait until it finishes. And you can click here. It basically tries to restart kernel and run all cells, and hopefully no errors we will have in the after execution. So yeah, just try to run this. And if you see something like this, it means that the notebook is running, and we can see that we create a list with name something like this. It can be different with yours, so it is fine to have different name. And you can see the list is now active, and this is the longest time to complete, which is waiting for server to start. So I will wait for this, and until we can connect using SSH, then it means that we can run and set up the experiment itself. The execution of the setup notebook file is done. We can see the output. It will be similar to this, which is we run the ls command inside the Spark directory, and we can see there's a new file called session.json. If we open this, basically try to see the floating IP of the instance of the experiment containers that we will use for this experiment. Now, after running the setup, then in the README, we will run the experiment. So again, just double click this, and we can see there's the output that I've already done. So again, just try to click this button, which will restart the kernel and run all cells. And again, click restart. The notebook will run the experiment, and you can see here we have the sanity check, where in this execution we will check the necessary requirements to run the experiment, and after that we will run the reproducing experiments, which is the Spark 34087 bugs, and this is actually the scalability bugs. And you can see here we will try to kill all the Java process if there exists, and also put the Spark reproduce scale bug suite inside this specific directory in the Spark code base. And you can see the code here. I took this from the GitHub pull request itself to fix the bugs, but in this case they try to reproduce it by try to cloning the session. It's where we can run the loop here and then try to clone the session every time inside the loop. And in this case we will trigger the system GC itself. Because we trigger the system GC itself and we put the waiting sleep code here, it means that every session that actually unused should be deleted, should be garbage collected by GVM itself. But the problem is because the cloning session will try to add the execution listener bus into the async event queue, it means that the reference of this session and the reference of the listener will be kept inside the async event queue, and it means that the reference is still live, and it means that the JVM cannot mark it as garbage. So as we know that clone session is used throughout the Spark code base, and throughout the time, it means that the memory will be leaked. Memory will keep increasing because there's no way for GVM to mark it as garbage. So we will wait until the experiment is done, and after the experiment is done, you can see that we try to put the output of the execution inside the alt stdout file, which you can see in this folder. This is you can see here there's a lot of output here, but the output that we want to have is this lines, which prefix with the repro keyword to make it easier for parsing this whole log file. As you can see here, I put out like 10 minutes timeout because it is hard for us to know when will the Scala test completed. So I set up the 10 minutes timeout because I know that based on my configuration, based on the variables that I put in this experiment, it should not take more than 10 minutes. Yep. So after the experiment is completed, which is should be like around 10 minutes because of the timeout, or maybe you can tweak it to get the out of memory faster by tweaking the run experiment sh inside the scripts folder. We can try to run the next notebook file, which is the analysis IPYNB right here. So what the analysis notebook file will do is try to parse the std out from running the experiment, and then we will try to plot the results. And this is actually the last step of reproducing this bug, and just try to run this, which will be fast. And it is done parsing the file, and now it's plotting, and it's done. And you can see here there's a lot of variables here, but basically this is the way GVM like hold the heap, hold the memory, reserve the memory from the system, and they consist of like the max memory, which is the number of memory that we specify when we run the experiment, and then we have the free memory here, and then the total memory and use memory. And as you can see, the use memory is getting like increasing every listeners every time the listener increase as well. And you can see here the listener versus sessions, which should not be like this because every time we run the GC, as you can see in the Spark reproduce scalability-bugs suite file, we try to run the GC, and it means that there should be any like several session that actually unused will be kicked out from the Java heap, or from the Java itself, because it will be garbage collected. But the reference, because the reference is still being held by the active sync queue, because of the execution listener bus hold that session as well, and the reference is still active, it means that the JVM cannot garbage collected those references. And it means that the number, if we try to clone the sessions, which I've already told you that several of like Spark internal Spark cloning the session internally, it means that every time they clone the session, the number of listeners will keep growing up, and it means that the number of memory will be increasing as well, because they cannot be affected from the or garbage collected from the Java heap itself. As I mentioned before in the README, we can see the fix of these scalability bugs inside the pull request from the developer, and they explain it really well. Basically try to clean up the listener and also the session when the session is actually garbage collected. So it means that the session now is garbage collectible, and it means that the memory leak will not happen in the future. And they also provide us with the tasks. It means that in the future it should be, these kind of things will be catched in the future before releasing it to the public. And it is quite good and simple experiment, and I hope you enjoy it so far. And yeah, happy experimenting, and try to tweak this experiment, and hopefully you will find this experiment useful. Thank you.